students of all class 8 students. Today, this morning, we are going to start our chapter called Square, Cubes and their Roots from class 8 mathematics. So what is a square? Multiple of any two equal numbers is called square. I repeat again. Multiple of any two equal numbers is called square. For example, here given 2 into 2, 2 into 2, 2 is the 2 and 2 is the equal numbers. 2 into 2, we can express it as 2 square or 4. 3 into 3, we can express it as 3 square or 9. 4 into 4, we can express it as 4 square or 16. 5 into 5, we can express it as 5 square. 6 into 6, we can express it as 6 square. So all these numbers are called square. And what is a perfect square? A number is called a perfect square if it is multiple of two equal numbers. For example, a into a square. 2 into 2, 4, 4 is a perfect square. 3 into 3, 9, 9 is a perfect square. 4 into 4, 16, 16 is a perfect square. So we come to know what is a square and what is a perfect square. The second topic is how to determine a perfect square. We can determine a perfect square for small numbers like 4, 9, 16, 25. It is very easy. Let me take you an example for a big number 484. To find out whether 484 is a perfect square or not, the first step what we have to do is that we have to take the prime factorization method. Write the numbers as the product of its prime factors. So 2, 2 2s are 4, 2 4s are 8, 2 2. Then again find the prime factors of 2 again. Then 121 coming out, then 11, we got it. Then all these prime factors make it as a pair, 2 into 2, 11 into 11. So here we got 2 square into 11 square, 2 into 2, 2 into 11 whole square. So here becomes 22 square. So make pair of the same numbers of prime factors. So all these prime factors we are to make the pair of the prime factors and check. Number third point is check for unpaired factors. So here there is no any unpaired factors. So this number is a perfect square. Else, if there is any unpaired factors, then that is not a perfect square. While we are studying the square, cubes and their roots, we have to know the properties of a square number. Because while we are studying anything, we have to know the property first, then we can do all the sums correctly. For example, if you want to know the characteristics or the properties of a number, perfect square number, then we have to know the properties. Property number 1 is that square of an even number is always even. For example, 2 square is 4, 4 is an even number. 4 square is a 16, 4 is an even number, 16 is also an even number. 6 square, 6 is an even number. 6 square is 36, 36 is also even number. We can add here 8 square is also, 8 is also even number, 64 is also an even number. Second property of a square is that square of odd numbers is always odd. 1 square is 1, 1 is an odd number. 3 is an odd number, 3 square is 9, 9 is an odd number. 5 square, 5 is an odd number, 5 square is 25, 25 is an odd number. 7 square, 7 is an odd number, 7 square is 49, 49 is also an odd number. The third properties of a square is that square of a number, whether it is positive or negative, it is always positive. Here 3 square is 9, 9 is positive, 3 is also positive. Minus 3 is negative, but minus 3 whole square comes out 9 and this 9 is positive. Therefore, negative square is also positive, positive square is also positive. A number ending with 2, 3, 7, 8 are not perfect square. So if you know the properties very nicely, you can recognize whether a number is perfect square or not. For example, number ending with 3, 13 is not a perfect square. Number ending with 2, 42 is not a perfect square. Number ending with 7, 57 is not a perfect square. Number ending with 8, 88 is not a perfect square. So you will have to keep it in mind that 2, 3, 7, 8. Number ending with 2, 3, 7 and 8 are not perfect square. Another property is that a number ending with odd numbers of zeros is never a perfect square. For example, here 1, 2, 3, 3 zeros, odd number. Here 1 0, odd number. Here 3 0, odd number. You can take it as here 1 5 0 0 0 0 0. Here zeros are odd numbers. How many zeros are there? 1 2 3 4 5, odd number. So all these numbers can never be a perfect square. Now we have last remaining 4 properties. The sixth property is if a number has 1 or 9 in its unit place, then its square ends with 1. For example, here 1 square is 1 ending with 1, or unit place is 9, 9 square is 81. So here 11 square unit place is ending with 1, so we get here 1 2 1, it comes. 19 square unit place is 9, so 3 6 1 unit place becomes 1. That means whether the unit place is 1 or 9, 1 or 9, 1 or 9, then the square ends with 1. It ends with 1. If a number has 2 or 8 in the unit place, for example, here 2 in the unit place, here 8 in the unit place, then the square ends with 4. 4, 4, 4 ends with 4. 2 and 8 in the unit place, 2 in the unit place, 8 in the unit place, then the square ends with 4. If a number has 3 or 7 in the unit place, for example 3 unit place, 7 unit place, 3 unit place, then it ends with 9. It ends with 9. It ends with 9. If a number has 4 or 6 in the unit place, here 4, here 6 in the unit place, here 4 in the unit place, here 6 in the unit place, then the square ends with 6. Here 4, here ends with 6, here 6 ends with 6. Now, after completing all these things, you can do as your homework exercise 3.1. Exercise 3.1, after completing all these things, you can take as your homework exercise 3.1, question number 1 to question number 7 as your homework. As the vacation ends, I am going to ask all these properties to you all, and I am going to check all the questions of exercise 3.1. The next topic from this chapter is we are going to study about the Pythagorean triplet. So how this Pythagorean triplet comes? Pythagoras, a Greek mathematician, he was an ancient Greek mathematician. He introduced a theorem from a right angle triangle, that is hypotenuse square equals to base square plus perpendicular square. So here we get 1 quantity, 2 quantity, 3 quantities. So this is 3 quantities, that is why we call it as triplet. So here we get it, suppose 5 square is 3 square plus 4 square. 5 square is 25, 3 square is 9, 4 square is 16, 9 plus 16 is 25. Another example I will give you, 8 square plus 6 square equals to 10 square. 10 square is 100, 6 square is 36, 8 square is 64, 64 plus 36 is 100. So this kind of numbers is called as Pythagorean triplet. And in every natural number, this Pythagorean triplet has, for every natural number there is a Pythagorean triplet, except for 1. For 1 there is no any Pythagorean triplet. But for 2, for 3, for 4, 5, 6, every natural number has Pythagorean triplet. For example, if we take it a natural number n, maybe 2, maybe 3, maybe 4, then 2n, n square minus 1 and n square plus 1 is the Pythagorean triplet. 2n, I repeat again, 2n, n square minus 1, n square plus 1 is the Pythagorean triplet for any natural number. So, if we take it n equals to 2, then 2n is 2 into 2, n square minus 1 is 2 square minus 1, n square plus 1 is 2 square plus 1, that is 2 into 2 is 4, 2 square minus 1 is 3, 2 square plus 1 is 5, so this is the Pythagorean triplet for natural number 2. For natural number 3, 2 into 3, 3 square minus 1, 3 square plus 1, so 2 into 3 is 6, 3 square minus 1 is 8, 3 square plus 1 is 10, so this is the Pythagorean triplet for natural number 3. Natural number 4, 2 into 4, 4 square minus 1, 4 square plus 1, that is 2 4s are 8, 4 square minus 1 is 15, 4 square plus 1 is 17. So this is the Pythagorean triplet for natural number 4. Therefore, I want to give you the homework for natural number 5, natural number 6, natural number 7 to find out the Pythagorean triplet. And you can continue as your homework exercise 3.1, question number 6, 7 and 8.
Stay home, stay safe, do it for yourselves, do it for your family, do it for India. Let's break the chain of COVID-19. Hum honge kamyab. Jai Hind.